Okay.
Okay, please
So,
start again. Yeah.
okay. Good afternoon, Mr. Dedi and Mrs. Lydia. So today, me and Elga, we're gonna present a little bit of our progress on our mechanical support for SMA patient. Uh, so SMA is a spinal muscular atrophy. It is a neuromuscular disorder. It is caused by loss of special nerve cells. So basically, the muscle is still okay, but there are some sparks on the neuron systems that occur some problem right there, and it usually will complicate to the muscle weakness condition. So what are we going to do is to build an arm mechanical support that could support the movement of the designated part of the arm. On our focus, on this project, we're gonna focusing on the upper part of the arm, and it we made it we make it so then the children could train the muscle so that he could strengthen it, and then with the device itself it will prevent extreme movement of the arm, so then it won't go too far from so then the joint won't be broken and the bones, and also it will support their daily activities. So our target function for this device is to create 1 degree of freedom of the upper arm, the abduction and adduction, and to smoothen the movement of the mechanical system, which Elga will explain it more later. And by the use of the sensor, we're gonna detect the neural activities and to actuate the muscle activities by the motor. So this is the basic principle of design, and Elga will explain it more. Nggak, belum di mute, belum di unmute.
Okay, so first of all, can you see my pointer?
No. I need to stop share first, yeah.
Because I use annotation. Can you see or
No.
no? So okay. So what should I do?
If,
Wait.
if you use annotation, annotation cannot be used as a mouse pointer. You can just be directly right there.
Okay, so there is this is basically our roughly design motor. We use motor for its pulley. We use pulley here that only has 2 ropes. The first rope is attached to the sleeve, and the other side is attached to the uh, spring, and the spring is attached to the static surface. And for the sleeve, for the sleeve,
I cannot hear anything, Helga.
I will explain. Sorry,
Helga, I cannot hear
can
anything.
you hear?
Can you repeat? You said something pulley, and but I can't hear.
Your voice was cut for some few
Okay.
seconds.
Maybe I will use microphone. Work. Hello? Test?
Yes.
Hello, test?
Yeah.
Is it better?
Yeah.
Okay, try it.
Okay, so this is our roughly design. So the first one is sleeve here. The sleeve that has rope and also rod and fabric. I will explain it more later. And this is the rope. Rope will so the pulley has 2 sides. The first one attached to the sleeve, and the second one attached to the spring. The spring itself attached to the static surface.
Helga, I lost your voice again. Hello?
I think there is internet problem because the picture is also frozen.
Yeah, maybe.
Maybe Gary, you
And
can. Okay.
here we had a motor and pulley. We're gonna use with condition when the arm is in adduction condition.
What is
Sorry, Bu.
what is buttress?
Buttress is just for penampang, just for surface, because pulley and motor it's above of his head, so should be there is a surface to stabilize it.
Okay.
It just maybe we can use it's depend on the pulley and motor. If it is too heavy, maybe we have to use like iron or something that it's more stable. But I suggest for the what's, how can I call this, penampang here, penampang, and I think this one should be iron because it should be as strong as possible.
Okay. Yeah, okay, carry on. I will give you some feedback later.
Yeah. Can you please nah? This one when his arm in abduction condition. So here, if you can see, there is a rod and this is the rope. I'm not sure we should divide the force into 3 ropes to attach to the rod. I'm not sure because if I just in the middle using 1 rope and then pull the arm just using one rope, it will be working or not. I'm not sure, but this is our roughly design, and so it will be like this. Sorry, here. Next slide. And this is for the MMG sensor. It's just for upper body. And here I use Velcro here because I think it's more easier for the children, for the patient to wear it because it just use like this and then attach the Velcro and that's it. So this is the MMG sensor. I'm not decided yet. We're not decided yet where should we put the sensor, MMG sensor, on the fabric. And here, please. And this is for the sleeve design. There's a very stick Velcro because because it should be deal with the pushing from the rope. And this is the stick fabric. Maybe stick fabric is like jean or something that not really stretch and not too delicate. And this is the road. The road is just basically this is sleeve design. It's I'm inspired by tensimeter. If you can imagine using tensimeter sleeve, yeah, it's like this. So I think it's enough. It's strong enough for this project. Yeah. And we try to find the stiffness of the spring. So I use work energy for determining K, and then we got K is 196. But maybe if we did mistake in the calculation, yeah, maybe we can revise it for later. So, but I don't know. Honestly, I don't know. How can we buy the spring in the market with the if we have specific K? For example, like we have K 100, but where can we find it? Yes, like so. Okay, please.
So for our next steps to development, we're gonna try to do some recalculations and to apply it in the real data, and also try to revise the design and make it more realistic. And then we're gonna choose the pulley and the motor, and this is our references. That's it.
Okay. First, I want to tell about the placement of the motor. You place the motor quite at the top. I think it's quite dangerous. If there is something directly on top of the children, if there is something happen when we push them around and it will collapse. My suggestion is probably you need to make some other mechanism to put the motor nearer to the back of the chair. You can still use that mechanism pulley at the top, but make sure the weight at the top is not that much. If it's only pulley, then it's okay. But if you put motor, the whole chair can collapse back because there is a lever arm there. And second one is about the material for the one that the fast. Probably you need to make it a bit stretchy. Don't use a stiff one. It's just a note from me. If you use the stiff one, then it cannot move with the body. For the sleeve, it's okay. I think you must make if you are inspired by the 10 centimeter, then you need to make it smaller to fit the child size. Yeah, and you also need to make sure that it doesn't move around. Probably you need to make two maybe together, so some of it can attach here, but there is something that can attach on the joint. Otherwise, it will move up and down.
Bu Lydia, maybe you can draw it in if you share screen and whiteboard. There is a whiteboard in the Zoom. You can draw if you have.
Maybe I can just draw it like this. Can you see it?
Cannot see it. Can you use the whiteboard, for example, if I share now the whiteboard?
In Zoom. Oh, which one?
Yeah,
How?
yeah. Well, you can use it in your share screen. If you click share screen, then there
Okay.
is an option to choose whiteboard there. Now you can draw there over there.
Okay. Okay. Wait a minute. Um,
We can see the whiteboard, but we cannot see anything yet on the whiteboard.
Okay, right. I'll try again. Okay. If this is the arm of the child, okay. Can you see it?
No, not yet. No. Maybe even I can draw it here. For example, like this, the arm using, but I'm using annotate now. So
Okay, I draw it here. If it's don't be too big like this, and okay.
are you drawing on the whiteboard or online, or are you drawing somewhere else?
Online.
Online, because we cannot see it yet in the Zoom whiteboard.
Maybe I don't know. I just download it then.
Okay, okay.
I'll try to share the one. Screen maybe.
Yeah, share screen. You can use share screen.
You can see what's in my screen now. Can you?
No, not yet.
Oh, okay. Then
Now, yes, it starts sharing. Yes, we can see it now.
okay then. Okay. Let me try again. Maybe pen out. Screen right, maybe. Sorry, yeah. This chart first. Sorry. Can you see my board?
Yep.
Yes.
Okay. For example, this is the hand of the child. Can you see it?
Yeah.
Yes.
The arm.
Quite thin.
Okay. Quite thin. Okay. Let me do another one. Is it better?
Yes, much better.
Yep.
Okay. Now I'll draw the sleeve doesn't need to that big, smaller, but then it's better, I think, if you have another one here so that it doesn't slide up and down. This is only a touch, very, very flexible here. This is just to prevent it from sliding. Can you see what I mean?
Yeah, but
Okay. We'll get back.
but both of them are attached each other, right?
Yeah, but it's very light attached. It doesn't be to be stiff. The one at the top is just to prevent it from sliding forward and backwards. Okay then. I stop sharing first. Okay. So you see what I mean, yeah? With the one. The third one is about the spring. If you use a normal spring, then the K will be changed, I think. If you buy it from the if you make it the coiled spring, it changes the range. It doesn't have a constant K. So how about using a counterweight first to start? And then after using counterweight, when you're using counterweight, maybe it is not that safe to move it around but just for the activity. And it can be attached there, and it can be tailored to the size of the weight of the arm itself. And you can approximate the hand on probably using it upwards and then back and then down again, using maybe a small child or even yourself to have an idea of the range of the weight that's needed. I usually experiment from the weight. We can use something like maybe sand, or also even rice. You can use that as well, and you can put it in a bottle of mineral water, and so it doesn't need to be very expensive. If you have a counterweight for the sport, then fine, use it. I think that's how you can approximate. I think it will work if you make a counterweight like that. Maybe there is another inputs from any of you, or even Pak Dedi.
Yeah, counterweight can be used also. Yeah, but the drawback will be you need some place, yeah, to put that, yeah, in the setup. And I don't know, Elga or Gary, did you already get from Andrew maybe the weight or the mass of the arm of the SMA children?
Yes, yes. He sent me the email of this data. Yeah.
Okay, that's good then. You can use
Yeah.
that.
Yeah.
Yeah,
What's
I
the
can
mass?
suggest again, if you can use more than one pulley. You don't need to rely on one pulley, and that pulley can make the weight
Lighter,
not
yeah.
hanging down, and you can make it at the back, for example, of the child, and yeah, you can make it lighter by varying the size of the pulley. Okay, but if you make it lighter, then make sure that it has enough space to go up and down, because you don't need to have much movement here anyway. You just need to a little bit like that so that they can do the activity. Okay, so you decided that it's hanging, yeah, it's not something that come from the table. Are you sure about it, or maybe you want to think of another mechanism? If I do it with other students, I normally ask for more than one alternative. But if your time is short, then okay, go forward with this one.
Yeah. Okay, Bu. Yeah, I think more than one pulley is yeah, we can consider it. I have question. Or Pak Dedi wants to give us input first or feedback, or
For now, not really, yeah. So because for me, of course, as a as a engineer, I would like something which is very small, compact. Yeah. So actually, no pulley, if possible, is really integrated. But maybe technologically, it is not easy to do. Yeah. Technically, it requires also some advanced engineering, with maybe more. Also, maybe a little bit expensive, yeah, because then you need some different mechanism. So yeah, I think for now we just aim something simple, yeah, simple and cheap, okay, and can be easily implementable. Yeah. So
I think that we need to prove the concept for now.
yes, we need to prove the
If
concept.
you can get a proof of concept, that will be good. I mean,
Yeah.
I also agree with Mr. Dedi. Actually, I want to something that come out from the or probably like a mouse, even you have a mouse that can go up and down like that, and with some mechanism to turn from the screw, so that it can be like some leverage to go up and down. But it's okay. I think we carry on with this one just to prove the concept. If you can make the child activate their muscle and it's go up and down, then it will be enough, I think, for this project.
Yeah, I agree. So because last year was a failure because they tried to use brute motor force, and then the motor does not have enough torque to move the whole arm because it was centered here, so no leverage at all. So that's why it required a lot of torque. So now your design either to have a pulley or to have a counterweight, or sorry, spring or counterweight, right? So so try to, if you use counterweight, but it means maybe more space required. Yeah. If you use spring, maybe it's more compact, but as Ibu Lydia mentioned, maybe then the range of the spring, the stiffness will be very fixed. It cannot be adjustable. Although there are some technology, new technology to do that, adjustable stiffness, but that will be for later. So that will be more too complex to make it now. Yeah, so we can make it as a pulley with counterweight, and depending on the situation, if because if the counterweight is too heavy, also it will not be safe. So to make it lighter, then you require multiple pulley, right? Like you learn in the statics of particle in the first chapter. Remember, yeah, with multiple pulleys, so that then the weight become 2T, right, or 3T, something like that. But then it means it will require more space for the ropes. So this is something also to consider. So usually in engineering we have uh, advantages and shortcoming, yeah? Advantage and drawback, and you need to optimize. What will be the optimum weight? What will be the optimum number of rope? Yeah, and where will it be placed, etc. So even though now the design will be using something that hang above the children, but if possible, not too bulky, not too heavy above it. So it will not create too much of additional burden for the children to move the wheelchair, for example. Yeah, okay. Gary, Elga. That's
Yep.
my.
Thank you, Pak Dedi, Bu Lydia. I have question. Uh, can we move the arm diagonally? Diagonal? Because if it is a straight like this, I don't know. We need pulley that in the line to
Yeah,
the
that's why it will be maybe not for.
movement of
For
the
now,
arm.
it's too complex.
Okay.
For now, it's too complex. So because this is the first time, ideally, if you could make a 2 degree of freedom, it can be combined using a certain control algorithm, this axis and that axis, right? Combined so that then the children can move it diagonally. But for now, as 2 weeks ago, Ibu Lydia has suggested, simple first, 1 degree of freedom, just as a proof of concept. Yang gini ya, abduction and adduction, right? We have
Mhm.
agreed, if I'm not mistaken, I forgot.
It's okay. I think that's okay. I mean, that's still 1 degree of freedom, but it's diagonal. Is that what you mean, Elga? It's still just one up and down, but it's diagonal. That it's okay. Um, the aim is so that it doesn't have to be in the same plane as this one. As long as it's still activated by the same muscle that's doing abduction, I think it's okay. What do you think? It doesn't need to be 2 degrees of freedom, just 1 degree. You just need to move it up and down. But you can
Yeah,
choose which plane
because
are
I
you.
consider, yeah, because if the pulley just right back of the children, so it will like pull diagonal. I put diagonal, so it will still can have space for the counterweight and also for the rope to attach to the
Yes,
arm. Can you
I
get it?
agree. Yeah.
What I mean?
Yeah. Okay. That's fine for me. So that from the top,
Thank you.
okay, I'll draw it. Let me share.
Yeah.
I forgot how do I just share my screen then.
Yep.
Okay, where is my pen up? Did you see my pen up?
Yes, I can see.
Okay. So from the top, if this is a child, and this is the arm here, are you saying that you want to so that the pulley can go this way? Is it and this is the counterweight? Is that what you mean?
Yes.
So that the counterweight can be put here instead of here.
Yeah, because both they should be in one line, right?
Okay. For me it's okay that way. I don't know about Pak Dedi. What do you think?
Yeah, as long as still 1 degree of freedom, I don't mind. So um, for now, for your batch, keep it simple. Yeah.
As long as it works.
Yeah,
It
as
has
long
to
as it
work.
works and prove the concept. Next year, I will ask the next batch. The next batch has more students. Next batch has about 7 or 8 students, so I can divide into 2 groups and propose different idea. For example, 2 or 3 groups and propose different idea. For your group now, because you only consist of 2 of your batch, you just use one. Just prove that it can work. We can have, because last year, even though there are 5 of them, they could not make it work. So for now, try to make it work. So do not make it too complex, too complicated. Uh, Bring some components also easily available in the market from Tokopedia, the motor, the weight, yeah, the counterweight, etc. And the pulley also, pulley rope also. These are something which you need to consider.
Consider also the stiffness of the pulley, yeah.
Pulley.
And the stiffness of the rope, because last year I think there's a student that used the rope from the bike, and it's too stiff. It doesn't move quite right. Yeah, I think that's it for now. 1 degree of freedom, counterweight. What else? Can you summarize, Gary?
Summarize dari apanya, Bu?
Of the discussion.
Oh, yeah, I took a note a bit of it.
Yes.
So
Good.
first we need to take attention to the height of the motor, because it will bahaya buat anaknya kalau itu jatuh. And then we need to make the sleeve to 2 parts, lower parts of the arm and the upper part, and make it even smaller. And also the rope, the stiffness of the rope. Terus juga tadi yang pulinya, we gonna make it a variant size and make it on 1 degree of freedom.
Okay, that's fine. Regarding the one that's last year, probably if we choose a geared motor, it can still work, Pak Dedi.
Okay.
If we use a higher torque of motor, it doesn't. Yeah, but they need to calculate what the torque needed. I still have some motor that not very expensive to move it, but it's very slow. It is very slow. But the torque can be quite high. So if the previous one, their prototype doesn't work, it means that maybe they haven't calculated what torque is needed and whether the motor needs some reduction or not.
Okay, thank you very much, Elga and Gary. Thank you very much also Lydia, because time is up. I have put an assignment in the Google Classroom, Elga and Gary. So please upload the PowerPoint that you have presented today, as well as maybe other supporting material to there. Upload it by tomorrow. I put the deadline tomorrow. Yeah. Each of you can submit the same file. So because this is a group project, right? So submit just the same file. It's okay. But then I will put the mark for today's presentation in that thing, based on my judgment as well as Ibu Lydia's evaluation. And Then what else? Next week, 2 weeks from now, please be prepared, okay, to improve something. What else? Yeah. Oh yeah, don't forget the online attendance. Elga and Gary, the OTP today is for this hour is 1020. Yeah, Biomechanics, week 7, session 3. OTP is 1020. Okay, with that, thank you very much. I would like to conclude this session. Thank you very much, Ibu Lydia, for your time, and see you again 2 weeks from now, hopefully, inshallah. Okay,
Thank you
bye-bye,
very
everyone.
much. Yeah.
Thank you, Bu Lydia.
Thank you.
Bye,
Bye-bye.
everyone. See you. Bye.
Thank you, Pak.
Yeah, thank you.
Thank you.